the compass is go slow on the ones you know. If you know a problem, nothing is worse than missing that problem because you go, oh, that's easy, and you make a careless mistake. Make sure if the problem looks familiar at all that you go very slow, check your answer, write it down on paper before you submit that answer on the computer. Some general strategies when you're doing the compass: write on paper. I don't know how many students that I see miss a problem because they just try to do it in their head on the computer. Please, please, please write it down on paper. Make sure you do not make a mistake. Use good technique on every question. Good technique are these things right here. Read slowly and in phrases and write down important information. Make sure you understand the question before you start solving it. Make sure you've answered the question and check as you go. You cannot come back to a problem on the compass. Once you submit your answer, I think they have you submit it twice before it actually goes in. So make sure you're checking it as you go. We're going to talk about different strategies, and one strategy is using mathematics, and this is the one I want students to be able to do. You've had 3-4 math classes in high school that has taught you information. Use that information to solve these problems. Let's look at it. In the figure below, where triangle ABC is similar to triangle KLM, lengths are given in centimeters. What is the perimeter in centimeters of triangle ABC? The fact that these triangles are similar is important, and they're talking about the perimeter is important. You have to know what perimeter is, and that's the distance around this. So on this triangle right here, the perimeter would be 12.5 plus 7.5 plus 15. And again, you can add that in your head or you can add it on the calculator. I don't care which, but when you add those together, you end up with 35 centimeters. I can't find the perimeter of this little triangle. That's actually what they're asking me to find. The two triangles being similar has to be important information for me. And in this case, when I have similar triangles, I can set up a proportion. And if you remember, we used to work with proportions. I have to make a choice as to whether I'm going to be going small to large or large to small. I'm going to choose small to large. So over on my small triangle, the piece of information that I have is this length of AC. So I'm going to put 3 down for that over my large triangle. So I want a corresponding side for that, and that's going to be KM. And that's 7.5. That has to be equal to. Now I could put AB over 12.5, or I could put BC over 15 to find out what those sides would be. But my question asked for the perimeter. So I'm just going to look at the perimeter of that. Perimeter over, and now I need the perimeter of the large triangle, and I've already found that to be 35. This is my proportion. When I solve this, I cross multiply. 7.5p equals 3 times 35 gives me 105. I want to solve, divide by 7.5, and I end up with p equals 14. So I have 14 centimeters would be the perimeter of that triangle. And I come here, and B is my answer. That's one strategy, and that's always the strategy I look at when I'm working math problems. However, let's say I look at that and I'm going, I can't remember how to set this problem up. I know what perimeter is, but I don't understand about the proportions. Estimation sometimes is close enough so that on this particular problem, I'm not going to reread it, I'm still looking for my perimeter. And as I look at this problem, I am going to compare this 3 and this 7.5. I do know that the perimeter of that we found to be 35. So I'm going to look at that piece of information. 3 is less than half of 7.5. So when I'm looking at the perimeter, I know that it's going to have to be less than half of 35. So over here on my answers, this 71 3/4 I can throw out. This 35 I can throw out. So I'm now really looking at 3 answers here. The 21.5 is not even half of that, or is more than half of that, so I'm going to go on and throw that answer out. I've now, just through common sense and looking at this problem, narrowed it down to 2 answers. I now have a 50% chance of getting the answer right. Again, hopefully you would guess the 14. My next strategy. Sometimes it's easier to check the choices working backwards than it is to solve the problem. Let's look at number 18 here. Janelle cut a board 30 feet long into 2 pieces. The ratio of the lengths of the 2 pieces is 2 to 3. What is the length to the nearest foot of the shorter piece? Well, immediately I know this is representing the shorter piece. And if I can't remember how to work ratio problems, then I'm going to take this problem and I'm going to deal with the fact that the board is 30 feet long. So if one side is 5 feet, the other side would be 25 feet. 6 feet and 24. 12 and 18. 15 and 15. Well, I can throw that answer out because that's not the shorter side. They would be the same size. And 18 and 12, again, I could throw that answer out. Now I'm looking for ratios of 2 to 3. If you remember when we work with ratios, I can just put this 5 over 25 and reduce it. 6 over 24 and 12 over 18. And when I reduce those fractions, this 12 over 18 is going to give me that ratio of 2 to 3. So 12 is the shorter side. H would be my answer. Now I have to say, mathematically, I can't go on without working this problem. If you've got the math skills, in my head, ratios of 2 to 3 is 2x to 3x. And if I add those two together, it has to give me 30 feet. 5x equals 30. Divide by 5, I get x equals 6. So my shorter piece would be 2 times 6, which is 12. I prefer this method, but I had that in my head. If you didn't have it in your head, you could work the same problem without algebra. Use that strategy.